Okay, this is 2003 BC, question number 1. It's an area and volume question. The first part of the problem asks you to find the area of region R. Now, one thing that's important is the top equation here is the square root of x, and the bottom equation here is e to the negative 3x. And this equation right here is the vertical line, x equals 1. So for A, we're going to go ahead and find the area of this region in here. The first thing we have to do is actually find the x value of that intersection point. So we want to know when the square root of x is equal to e to the negative 3x. So to figure that out, you would use your calculator, graph this in y1, this in y2, and find the intersection point. Then I would probably store that into a variable, so we can say a is equal to, in this case, 0.238734. If you have that written down, then you do not need to write that number every time you take an integral. You can just write a. Okay, so for part A, find the area of this region. We're going to take the integral from a to 1 of the function on the top minus the function on the bottom dx. Again, this is a calculator problem, so you plug this into your calculator and you would get 0.442 or 0.443. The second part of this problem says find the volume of the solid generated when R is revolved around the horizontal line y equals 1. So when it's revolved around the line that goes right across up here. Okay, I'm going to draw a new picture for that. So it's the same region, but it's revolved around this line, y equals 1. So what's going to happen is you're going to have any cross section is going to be, there's going to be a large radius and there's going to be a small radius. Okay, so each cross section is going to be a washer. And to do the washers, we're going to do a big radius and a small radius. The large radius is equal to 1 minus this e to the negative 3x. The small radius is then going to be 1 minus the square root of x, this distance here. The volume then of this solid is going to be pi times the integral from a to 1 of the large radius squared minus the small radius squared. And when you plug that into your calculator, you should get 1.423 or 1.424. The last part of this problem says find the region that is, or take this region and find the solid where this region is the base of the solid. And each cross section, instead of being revolved around like this, is actually it's perpendicular to the x-axis, so it comes straight up and down, and they are rectangles whose heights are 5 times the length of the base. Okay, so what you want to do on this one is, again, we're looking at the same region. And this is pretty hard to draw, but essentially we're going to take this region, and anywhere on it, the cross sections are going to be this, and they're going to be a height 5 times that. So to kind of draw it in perspective a little bit, you come way up here, and whatever this distance is, this is 5 of those distances. Okay, so we've got these functions that will define this distance here, and then the height of those are 5 times that. So what is that distance there? The distance is actually equal to the square root of x minus e to the negative 3x. And so then the height of those rectangles is 5 times that. Essentially what we're looking at is 5 times the square root of x minus e to the negative 3x. So we'd want to multiply length times width to find the area of one of the cross sections, and then integrate from a to 1. So the volume is actually going to be the integral from a to 1 of 5 times root x minus e to the negative 3x squared, because I'm multiplying this 5d by d, so I have that multiplied twice, which is why I get squared dx. When I plug that into my calculator, I'm going to get 1.554. Okay, so the main points of this come from 1 point for the integrand, okay, this part, root x to e to the negative 3x, 1 point, and 1 point for the answer, so 2 points for A in this problem. For B is worth 3 points, 1 point for the integrand, 1 point for the answer, and kind of one other point in here. There's a lot of different places where it says that you can miss points, but if you have part of this integrand right, you're going to get 1 point, and if you have the whole thing right, you're going to get 2 essentially. And then C is worth 3 points, 2 for this integrand being correct. If you just have this root x minus e to the negative 3x somewhere in there, then you're going to get 1 point, but you need the whole thing to get 2, and you need 1.554, 1 point for the answer. Now there's 1 point missing, and that's the limits of integration. So if you have the limits here or here or here correct, then you're going to get 1 point. You only need them one place anywhere to be correct to get that point.